So hey guys, in this video we are going to learn the curve fitting topic. So basically we are going to cover the basic terms of curve fitting and what are the methods used to find the best curve. So basically this idea is curve fitting, right? So we have to find the curve which basically fits the set of data given, right? So we are going to learn that method and we are taking up the example also in order to make you understand what is the basic idea of curve fitting, how we are going to find what are the terms involved, and we are going for the problems in the upcoming videos. Okay, that you have to understand. So here, so let us start. The curve fitting topic is there. So the basic definition which I have made more easier for you to understand, it is a process of finding. What we are going to find out? We are going to find out a mathematical equation. So basically, it will be a curve or the line that best matches, that the best matches a set of data points. So data points will be given. Okay. So set of data points will be given x, y values, whatever is the values of the variables given. We are going to find out a mathematical equation, basically a curve or the line that matches the data set given. Okay, more easier way it is given as basically we are going to draw a smooth curve or the line that follows the pattern of your data. So that means whatever the pattern of your data is there, that it should be following. What should be following? Curve or the line should be following. For example, I have taken one example. Now here we are having x values as well as the y values. Okay, so this is the data set given. So x values is 1 2 3, y values are 2 4 6. Now we need to find out a curve equation, mathematical equation. Basically, it should match the data set given, right? So if I write y is equal to 2x, whether this particular y is equal to 2x matches the data? Yes, of course it matches the data. Because if I substitute the x values given over here, I'll be getting corresponding y values, exact y values, right? So here, though x is nothing but the independent variable, so this also you need to understand. This is the independent variable. Now, why we are saying it is the independent variable? Because we are going to choose this, right? It is the input given, right? And what is the output we are going to get? We are going to get the output as y. So this is the dependent variable. Dependent variable which is basically the output or the cost which are going we are going to get. So it basically depends on the x value. Now can I say that this particular mathematical equation, the curve we have find out, basically is the best fit curve, right? It might be the best fit curve for the particular data given. It can be, right? It might be, because when you are substituting the x values, you are getting the exact y values, right? So this is the basic idea of what curve fitting. So data will be given, we are going to find out the equation. Now it won't be this much easier. I've just taken the simple data, we are going to just write it as, we are just taking it as y is equal to 2x for the simplicity purpose. So the method which I was saying is that it is called as the least square method, is the most commonly used method. Least square method, that means there is the involvement of square, there is the least, that means the less value we have to consider, minimize something. So this method, it is a method to find the best fitting curve, right? It is the method to find the best fitting curve or the line by minimizing. This is the important word we are having here. So we are going to minimize the total squared difference. So square word also came, right? So square difference between the actual data points and the value predicted by the curve. So this definition might be complicated. You won't be able to understand at the first go. Okay. But we are going to take up one example in order to make you understand what is basically this the least square method, or what is the best fitting curve or the line or the squared difference we are getting, actual data points, what is predicted, right? Expected data points. These all things we are going to learn. I'm going to take the x values as well as y values. Okay. So x I'm going to take 1, 2, 3. Y I'm going to take 2, 3, 5. Not any multiples or something, as I have taken before, y is equal to 2x, like simply we got. Now, this particular data set, a simple data set where we are having three data points, right? Corresponding x values, we are getting the y values. Now, we want to fit a line of which form? Y is equal to ax plus b. Simple form, right? We want to fit a line of this form. Let us assume that the final, whatever the equation or the curve we are going to get is y dash is equal to x plus 1, right? Basically means a value is 1, b value is 1. I am going to assume it. This is the last value we are getting. From last we are going to come to the first position, right? So I'm going to make one more table which is x value, y I, and y dash I value. So x value is basically we are going to copy paste the same thing. Y I value will be 2, 3, and 5. Y dash I value is we have to find out from this x plus 1, right? So what is this particular thing? This is the final curve we are getting based on these two values. So we have applied some, assume that we have applied least square method or any method, and we have got this particular equation, right? So based on this two data set, how we are approaching this, why we have got this particular thing. So what all things can be captured from this particular equation, what all terms we are going to understand. Let us focus on this. Okay, so we have to be patiently observing what all things is happening. So y dash is x plus 1. X plus 1 means 1 plus 1 is 2. This will become 3. This will become 4, right? Now what is residual? Residual is a term which basically means the error we are calculating. This equation which we got at the last after applying the method, y dash I and yi, both will be having some error, because this is the actual value and what we got at final will be the predicted value, right? This is the predicted value. As the definition says, there will be a actual data points as well as the predicted data points by the curve. So we are going to take the difference between those and square it and total it. Now residual will be for each particular point. This you have to understand. That is very important. So that means each point will be having, data points will be having the residual values, which is basically the error between the actual and the predicted. So one more column can I draw here? So here I am going to write one more thing, which is the residual, which is nothing but yi minus yi dash. So difference between these two, 2 minus 2 is 0, 3 minus 3 is 0, 5 minus 4 is 1. So we have got the residual values as well. Okay. So total squared difference, if you see the definition over here, total square definition here, total square difference. So we have to going to take the sum of differences. So sum of differences will be sum of yi minus yi dash. It is equal to 0 plus 0 plus 1, and it is equal to 1. Now this won't tell you that what whether the curve which we wrote is the best curve or not, right? This does not tell if the fit is good. It can be even 0 if positive, and negative errors cancel out. As we got the sum of differences, if I'm going to square it, because there is a word squared, so I'm going to square this particular thing, sum of squared errors. Basically we can call it at SSE. Okay, so what is sum of squared errors? It is basically you have to take the sum yi minus yi dash. Basically we have to square it. After squaring, so individually you can square and just add it up, right? So you'll be getting it as 1 itself. This sum of square is basically we are targeting. So always remember the sum of square we want to minimize in the least square method. The smaller the sum SSE, smaller the SSE, the the better the fit. Better the fit. What is the meaning of better fit? That means whatever the equation we have got, suppose this is the equation we are getting after applying this particular method. So this curve we got, this particular curve will be fitting into the data points. So data points, whatever was there, so this data point will exactly or will be close to this particular curve. We can say closeness is there. So smaller the SSE, the better the fit of the curve will be, right? So we are going to take one more example to make you understand what else is there. Now what happens if I change the line? Let us consider one more line. So let us take one more line. So suppose y dash is equal to x plus 0.5. Instead of 1 I have taken 0.5. Let us see what happens now, right? X value is there, y value is there, basically yi, and yi dash is there, then residual, which is the yi minus yi dash, difference of this. X value will remain same, 1, 2, 3. Y I also remains same, 2, 3, 5. Y I dash is basically put substitute here x value, x plus 0.5, 1 plus 0.5, 1.5, 3, sorry, not 3, 2 plus 0.5, 2.5, and here we are having 3.5. Then residual of each data point, we have to find out difference between these two, right? It is the 0.5, 0.5, 0.5, right? Now, now if you take SSC directly, so directly you are going to jump here, summation of yi minus yi dash square. So we'll be getting what? Whatever the values is there, just square it and sum it. So 0.5 square plus 0.5 square plus 0.5 square. So what will be the answer? 2.75. Now this particular value and this value you observe. So this value we can say this particular curve whatever we took, this is the worst than the previous curve, can we say? It is not the better fit because SSE whatever we are getting, it should be the smaller value. Always remember, smaller the SSE, the better the fit will be. But here if you observe, this is 1, this is 2.75. So which one will be better? Smaller value SSE will be better. Always remember, it is just I am just comparing these two curves and seeing for the given data set what is the SSE, based on SSE whether it is a good fit or not, right? Now at last of the video we are going to see the terms and their meanings very quickly. For that purpose let us see that. So let us try to understand 4 points over here, 4 terms basically. Okay. The first term is we can see that it is residual. So we have already discussed in the video itself that residual is basically the error which we are finding for each data point. So whatever the data point is there for that particular data point, we are going to find out the residual, right? And this is basically yi minus yi dash. Now yi is the actual whatever the data point is given in the question. Yi dash is the expected one or the predicted one which you are going to predict so that you will be getting the best fit or the curve which is relevant for the, which basically is the closely to the data points given. Okay. Second one is the sum of differences. So after finding the residual, whatever we have got, the error between the actual and expected, we are going to take the sum of that, summation. So sum of differences we are going to take, that is the total error we are going to get. Third point is the sum of squared differences. Squared differences we can say is that SSE. Okay. So square differences we are going to take. So after the second step, we are going to just take the square of that total error, which basically can be used to find whether the fit is good or not. Like we had in the example, we got 1 as well as 2.75 in the above examples by taking two different lines, right? Curves. So for that particular 1 and 2.5, we decided that we'll go for the smaller value of SSE, which is this third step over here, which basically denotes that, which basically indicates that it is the best curve. Okay, while we are comparing it. Now, the fourth step, we are going to deal with that in the upcoming videos, as we are going to solve many problems in regard to this, which is the least square method. As the name suggests, we are going to find the line or the curve that minimizes the squared error, which is basically indicating this third step, right? So least word, you can see that it basically denotes we are going to reduce something which is the squared error. Okay, so that method we'll be seeing in the upcoming videos step by step.